All right, guys, this is our third and final lesson for this week, and we're going to wrap up our surface area part here. So this will be our last part over surface area, which is surface area of spheres. Okay, the past two lessons you've seen prisms, you've seen cylinders. Yesterday you saw pyramids and you saw cones, and this will be the last one, which is our spheres. All right, so we have a lot of vocab here that we need to cover. All right, so in our essential understanding. A sphere is the set of all points in space that's equidistant. Again, remember, equidistant means equal distance from a given point called the center. A radius is a segment that has one endpoint at the center and the other endpoint on the sphere. A diameter is a segment passing through the center with endpoints on the sphere. So again, this is a great visual that we can see here. As we can tell, that dot in the middle of that sphere right there is our center. And then when it goes from the center to the side, that is our radius. And then the diameter would go from one endpoint to the other endpoint when it crosses through the center. Okay. You can find the surface area and the volume of a sphere when you know its radius. Again, we're not going to cover volume. We're just going to stick to surface area today. And when a plane and a sphere intersect in more than one point, the intersection is a circle. All right. If the center of a circle is also the center of the sphere, it is called a great circle. So again, if we think about that sphere and we if I put a paper right through there and if I lift that part up, the inside of that's going to be a circle. And all they said there was if I put that same paper right through the diameter of that sphere, right through the middle of there, and I picked it back up, it's going to be a bigger circle, but it's the biggest circle that it can be, and that's called a great circle. That's what it's called, the great circle. The circumference of a great circle is the circumference of the sphere. So again, if I were to pick that part up of the great circle, that's the biggest circle that it could be, that's also going to be the circumference of the sphere. A great circle divides a sphere into two hemispheres. So essentially, all we're doing there is just dividing that sphere into two congruent hemispheres. It's just cut in half. That's really all it is. So again, a lot of vocabulary there, guys, but just understand, the basis of what they're trying to say there. Okay. So we're going to go ahead and hop into a theorem here. And again, like I said, today we are just focusing on surface area. So the surface area of a sphere, here's the formula that we need here. SA equals 4 pi r squared. That's the formula. Make sure we're getting used to it. All right. So again, 4 pi r squared. So if you need to pause it, you need to write that down. Whatever you got to do, understand that's going to be the formula that we use. All right. So let's take a look at that here and let's move into our first example. So finding this area of a sphere. What's the surface area of the sphere in terms of pi? Now understand this one here. They gave us the diameter. Now, if I go back to my formula here, here's our formula, SA equals 4 pi r squared. So again, if they give us the diameter, we have to find the radius. So to go from a diameter to a radius, we're going to divide that by 2, which means our radius should be 5 meters. So again, all I'm going to do is plug in that 5 in for my radius right there, which is the r. And again, that should give us 4 pi 5 squared. So again, the first step is I have to get rid of that squared. 5 squared would give me 25, and then multiply that times 4. 4 quarters gives us 100. So again, that would simplify down to 100 pi. Make sure you know what they're asking you to solve for there. So this right here wants it in terms of pi, so that means you're not multiplying the pi into it. So your answer should be 100 pi. So again, understand what they're asking you to solve for. If they want it to the nearest tenth, then you multiply the pi into that number. If they want it in terms of pi, leave the pi alone. Just multiply the numbers on the outside. So again, that means the surface area for this equation here is 100 pi meters squared. Anytime we do area, your unit should always be squared. Make sure you understand that. Okay? All right. Example 2, finding surface area. The Earth's equator is about 24,902 miles long. What is the approximate surface area of Earth? And round to the nearest thousandth square miles. All right. So again, we're going to break this down into 2 steps. Our first step here is we need to find the radius. Remember, that was that great circle that we talked about. So again, if I slice that sphere into 2 congruent parts and then break them into hemispheres, we need to find the circumference of that. So again, remember, the shape of that great circle is a circle. So we're finding the circumference of a circle. For that formula, we're using 2 pi r. Okay, so that's the circumference of the circle. If that's the case, we know that the Earth's equator is about 24,902 miles long. That's the Earth's equator there. So again, that's our circumference. Remember, the equator goes around the Earth. So if that's the case, that is our circumference. So again, we're going to set that in for that circumference and set it equal to our formula of 2 pi r. From here, we need to get r by itself. So again, pi is a number, 3.14, and it goes on and on forever, right? So we're going to get r completely by itself by dividing 2 pi on both sides. So again, I would divide 24,902 by 2 pi. So again, we're going to get a decimal for our answer here. So again, if we use our calculator and we round, you should get right around 3,963.3 if you round. Okay, that is our radius. That's what we're going to end up using here. Now that we have the radius here, now we can go and solve for the surface area of our Earth, which is a sphere. So in step 2 here, now that we have our radius, we're going to plug that into our formula. Remember, that formula is 4 pi r squared. There's our formula right there. Knowing what our radius is now, I'm just going to plug in my answer right there and square it and multiply it times 4. Right now, again, they want it to the nearest square miles here. So again, we're not living in terms of pi here. So multiplying everything here. So I'm going to multiply that big number there, 3,963 point whatever it is, right, times 4 times pi. Multiply all that into your calculator, and you'll get a very, very big number there. And again, that tells us that the surface area comes out to be right around 1,387,000 miles squared. Again, right around. Okay. Again, understand that you need to solve for the radius first. So again, we can find our radius from circumference. Circumference is 2 pi r. So if they don't give you the radius, then more than likely they gave you what the circumference is and go backwards. So once you find your radius, then you can plug that radius back into our formula. So essentially, to find the surface area, all you need to do is find what the radius is. Once you have that, you should be able to go and just make sure you know, are you solving in terms of pi or are you rounding? Okay, that's all it's asking for. So we do have a shorter lesson here, guys. Since it's just surface area of a sphere, that's the only figure we're covering today. So I'm going to leave it at just that. So again, you will have homework over this. It's going to be due on Friday at 11:59 p.m. Again, this will be the last chance you have, which is today, for virtual office hours, which will be from 1 p.m. to 2 p.m. Remember, Friday we won't have it. I'll be busy Friday, so I cannot do that. If you have any questions, feel free to contact me, email me, get in touch with me, and I'll find any way that I can help you out. Okay. Other than that, guys, you have a great weekend, and just know that I'm here for you guys if you need me. Stay safe, and you guys enjoy your weekend. All right, guys. Bye.